Yeah, go ahead, please.
Yeah. So, good afternoon, everyone. Welcome to yet another knowledge session by Biome Environmental Trust. And today we have with us Praeda Modak. Praeda has completed her master's in sustainable interventions in the built environment from Polytechnic University of Catalonia, Barcelona. She holds a degree in Bachelor of Architecture from Iogen School of Architecture, Jaipur. She has 2 years of experience at Seri Architects, Mumbai, where she has worked on hospitality and residential projects. She has also completed an internship in Kolkata on sustainable architecture and construction and refurbishment, including the renovation of Allianz franchise do Bengale. During her internship, she has developed a strong interest in bamboo architecture, and she has also attended multiple workshops on bamboo and rammed earth construction. She has also worked on refurbishment of old heritage buildings during her master's. So today she's going to be taking a session on design with water, sustainable urban features. This is going to be her topic for the day. Welcome, Praida, and it's going to be wonderful
Thank
listening
you.
to you.
Thank you, Rajni. Thank you, Rajni, for the presentation, for the introduction. So, hello, everyone. Good evening. So, yeah, I'm Preda. And yeah, let's start. Am I audible properly? Okay. Okay, I'll start
Yes,
it.
yes, you are.
Yeah. So, yeah, as we know, starting with a quote question: how can cities thrive when the very water they rely on is both scarce and unpredictable? So as we know, water is very essential for the functioning of both natural and ecosystems and cities. But recently, in our recent days, as we see that natural water cycles are under increasing pressure from urban expansion, and which we see because of the population growth. And the water in the city, as we see, is typically exploited in a linear process in which most of it is polluted, treated, and discharged into the water bodies with like semi-treatment. Over the years, water is disconnected from its local territory and ecological processes. It has like completely disconnected and being treated as just a edge and nothing else. So, stormwater management is another example of this non-sustainable linear water process, as you see through these graphics, which we'll learn about in the presentation. So, yeah, as we hear from all over the presentations, from everywhere, from all the sources about the global water stress, that at the present, many of the world's urban population, almost 4 billion people, face water scarcity, and which is expected to double by 2050, which is due to urbanization, socio-economic development, etc., and which will increase the industrial and domestic water demand by 50 to 80% over the next 3 decades. So, at the same time, over 80% of wastewater globally is discharged into local water bodies without treatment. So, you see in these graphs like the water stress. And if we talk about India, in India, water has shaped India's civilization from Indus Valley hydraulic systems to colonial canal irrigation systems. So, India's water paradox is very stark, like from abundant annual rainfall, yet one of the most stressed nations. Groundwater sustains over 85% of the rural households, and which is being depleted in a alarmingly rate, and nearly around 600 million people face high to extreme water stress. So, yeah, as we say, cities must learn to flow with water and not fight against it. So, now I would start with my work. I would like to start with my work that I did during my master's in Barcelona. So, my master thesis titled Connecting Water Dynamics, which focused on developing design strategies that integrate stormwater, blue green infrastructure, landscape systems to create more resilient urban spaces. So we'll talk about it. It also studied actually the possibilities to close the water loop and at the neighborhood scale, at a smaller scale. So the study area, which is Barcelona, which lies in the Catalonian region. So the eastern Catalonian region faced very severe scarcity until last year. So Barcelona historically relies heavily on local rivers and aquifers, which supplies around 95% of the city's water. So they had a great drought in 2008, after which they shifted heavily on the desalinated water systems, and which met around 58% of the city's water supply. So, but it actually increased significantly their energy costs. So, this shows their transition and evolution of the resources in Barcelona. So, this is my study area. This is like the whole Bessos region. So, I'll explain this area first. So, as you see, this is Barcelona, and this Barcelona is the city of Barcelona is actually determined by geographical boundaries, like the two rivers on the east, on the each edges, and which are Bessos and Llobregat. And on the north, there is a hill range called Collserola, which determines its boundary. So, as you see in this map, can you see my cursor actually?
Yes, we can.
Okay, okay, okay. Yeah, so that's like the metropolitan area of Barcelona. So, and this one is the Besós Basin, this whole area in the Catalonian region. Since we are talking about the water, the river, so will talk about the basins, the river basins, primarily. So, and in Bessos Basin, I studied the small part, which was a very socially, economically vulnerable area of Barcelona, which is situated on the Bessos Basin, and we studied this area, this vulnerability through water. Like how can water be managed in such areas, and we see such areas in India as well. So yeah, so this is the neighborhood that I studied, and the Bessos Basin, the Bessos River, and 1 second, can I just yeah. Yes, sorry. Yeah, so this whole stretch I studied from the neighborhood to the Bessos River. So this is the river, and this whole stretch, like the ecological resilience, the ecological regeneration of this whole area. So yeah. So to begin with, it's very important when you study territory with of river. It's very important to start with reading the territory in terms of water and its flow, its pattern, its geomorphological patterns, palimpsests, if any. So this traces the shifting relationship between the water, land, and urbanization, from pre-industrial area to farmlands and canalization to efforts of renaturalizations by the communities and the community resilience. So it was to understand basically how the river evolved over the time, and its relationship with the community, and how it affects, how it changed from a river to just a boundary. So we studied that. So yeah, so this area, it lies between a Bessos River and a very historical river, which actually went down under the urbanization, which was covered. So it gives it a strong hydrological context. So it's very much rich in its wetness, and at the same time, it's also socioeconomically vulnerable areas of the city. The so because there were lots of migrants from during the industrialization who came here, and this area was built abruptly, so as you know. So the purpose of the study was to understand the city's water management through the urban water cycle or the ecosystemic cycle. And the study was done to understand the complexities of the urban water cycle through two-dimensional approach, technological and ecosystemical. So technological was the on through the energy point of view, and the ecosystemical through the nature-based solutions, which are WSUD, which is water sensitive urban design, and SUDS, sustainable urban designs, and etc. So it was also to recognize the big opportunity in the city and its vulnerable neighborhoods, social dynamics through water. So this is the area, this is the study area, and we We like study the water patterns in the city, which went down the urbanization. And until the mid 20th century, the urban landscape of Barcelona, which was deeply structured by water. So we see the evolution of the neighborhood, and this is the neighborhood which I took, which I studied. So you see this dream which was prevalent in earlier centuries and which went down during the urbanization. So we studied the evolution of the cities, of the territory. We also see the evolution of the urban river connectivity, how people connect with the river and how it changes over the time. So, although the river was buried under the urban form, but it still persists. Like in the poorly constructed buildings, there is like subsurface flows, infiltrating soils, and there's flooding. So you understand the challenges. So we studied the urban environment of the area, the NDVI, the presence of vegetation, and how all these vulnerabilities also affect water flow, water management. And it's very important to study these things, the flood level and everything. So, yeah, we went through the current water management plan of Barcelona, which obviously comes from the mix of groundwater, the surface water, the rivers, and aquifers, and sea for sure. And then there are treatment systems, and which then finally supplies to the Barcelona metropolitan region. And so this was Barcelona's water management has evolved into a complex multi-source system and which integrates surface water, groundwater, desalination, and reuse. So they also reuse the water, but it's very less percent. So yeah, so it translates actually the energy use of each treatment process, and which shows us that desalination is the most energy and carbon intensive. So these were all the sources, and we studied the water consumption. So this Barcelona water consumption map shows that the domestic water use per inhabitant by neighborhood. So the study area, that vulnerable area has one of the lowest consumption levels, which indicates it's related to the higher socioeconomic vulnerability, which affects the water consumption pattern. So these calculations show water energy carbon footprint link for this area called LAPAO. And by quantifying how much energy and CO2e are tied to the neighborhood's water consumption. So there was a water energy nexus which was required to calculate the energy connected with the water consumption. So this one shows the domestic water consumption breakdown in households. So I wanted to break it down into what all the activities which generate gray water and black water. So it was easier to calculate like how much water in a typical neighborhood can be reused and which cannot be reused, because here we'll talk about mostly gray water and rainwater, which can be treated by the nature-based solutions, and black water is still a limitation right now. So, yeah, the grey water that is collected and is calculated based on the available data from the municipality of Barcelona, and calculated grey water volumes help determine the potential reuse within the neighborhoods. So you see the final calculations that the grey water that can typically be collected and the potential reuse targets, which is not much. So there's always remaining water that you need to be recharged, which can help recharging the aquifers. So, also by assessing the climate of Barcelona, the physical characteristics, the surface material, the rooftop capacity, we also evaluated the potential of capturing and reusing the rainwater for household applications. So, here is a precipitation analysis of Barcelona, which was done, and on this whole neighborhood was like made into clusters where, based on the calculations, we proposed 16 tanks of capacity of 155 meter cube each, based on the rainwater harvesting and the capacity and the annual rainfall data. So we came, so as we know, like rainwater harvesting potential in a neighborhood, it's very helpful, and it can be used during the drought periods in multiple public infrastructure and utility use, urban cooling and heat island mitigation, and community uses. And so yeah, here this shows how decentralized grey water and the rainwater combined can significantly reduce a neighborhood's water demand and energy reuse. So you are not depending on the conventional technology, the desalination plants, and you're actually offsetting around 44% of water demand. So yeah. So this area has relatively high share of paved surfaces as prevalent these days as we see in the dense urban fabric, and like the urban areas have restricted permeability and very less permeability. So, but if we look at a bigger site, there are many unused spaces and more balanced and neglected and unused spaces which have a lot of potential which is not used. So we wanted to reconnect this area to the ecological roots, to the river as it was in the earlier days. So we studied the area, the pavement, the rooftop, the green areas, and how much percentage is the paved areas and the green areas, and how it can be changed and how it can be made more permeable. So this all study was done. So before I move on to the other part, in the interventions part, I would like to go through the sustainable urban drainage. And so sustainable urban drainage systems, which I was talking about SUDs, which are like integrated network of like vegetated areas or open spaces, that is green roofs, rain gardens, swales, porous pavements, which we hear every time during the nature-based solutions, which are used to protect natural ecosystem principles and functions and to offer a wide variety of benefits like to the ecosystem. So SUDs are basically proposed as targeted strategies to manage the runoff and reduce the flooding risks in the urban areas. So there are many technical solutions for facilitating these stormwater management systems in the landscape as well as in the buildings. So these solutions were developed as responses with to specific needs and site situations, each with unique characteristics. So it's according to the site situations and the advantages and disadvantages. So going to the rainwater harvesting, as we saw it earlier, so these are the cisterns. It can be underground and above ground. So these are mostly storage devices as we see. And then based on the treatment, then there are like bioretention areas in the landscape, which are vegetated basins, which allow the water to slowly infiltrate. It retains and then let it infiltrate into the soil slowly. It holds the water and doesn't let it flood. So then there are detention and infiltration trenches, which are linear excavated trenches, which are filled with gravels and porous materials, which stores the stormwater runoff and gradually infiltrates it into the subsoil. So a controlled infiltration. Then there is rooftop retention systems like the green roofs, which capture and temporarily store the rainfall in the buildings. Then there are permeable pavement, the surfaces which have spaces in between, which allow the water to infiltrate. It doesn't treat, but it lets the water to infiltrate without creating a barrier. Then we see kinds of infiltration zones. Then there are dry infiltration zones, which are designated ground areas with permeable soils, which lets it infiltration of. So all these are like site specific. Some are like only can be implemented along the highways, which can be some can be implemented in the parks. So these are very site specific, and it depends on the collection points of the area and the catchment areas. So it needs to be studied. The swales, like it can, you must have seen swales along the highways, and yeah. So geocellular systems, which are subsurface modular plastic units, which are storage voids underground, which holds the water and lets it infiltrate later, or it can be stored and can be reused later. Then there are detention ditches. So yeah. So later, like hydrological mapping, which is a very important part when we see all these SUDs, these strategies, and how to implement in the site, like how to put them. So GIS based hydrological mapping was conducted in the study, which actually provided very critical insights on to understand how the water flows, how the water moves across this region. So all this flow direction and accumulation and analysis revealed the concentrated runoff along the low-lying streets accumulation points. So you know what are the flood-prone areas. So this all studies were done, the channel extraction, the drainage basin delineation. So you know the natural flow corridors. So we overlapped it with the road patterns and saw where are the potential detention basins, where can we implement the rain gardens, or what are the potential SUDs, or see, these areas can be potential areas for the wetlands. And so this was the sewer system that was existing in the municipality maps. So, and you see the red areas, which are like the stressed areas when it rains heavily. So, you know, you have to lessen the stress on the sewer systems by creating a separate stormwater management system, which can be done by the SUDs. So, moving on to the interventions part. So, we see here, like based on the hydrological mapping, this was a kind of a model that I made, like for the potential SUD strategies and the wetland areas. So, this whole area, this was the highway part, which made this whole region unaccessible for the public, for the pedestrian, and it had a very much potential to be used to be changed into a ecological corridor near the river for the people, and it connected the neighborhood with the river, creating a small like a small island, like like which prevents the urban heat island and cooling microclimate. So Lapao is not merely a case study, but a model of like how low income and socially vulnerable neighborhoods can recover their lost relationship with water. So by examining the hydrological history of the site and its agricultural origins sustained by the river, and the study shows how water dynamics were gradually erased from the urban fabric, and we tried to restore that from like small interventions, like if it's possible. So there was a small pilot model for the for the neighborhood itself, for the area, that what if in a building for the different phases, for the further phases, if the gray water and the black water is separated and the rainwater is also separated and is used for the community gardens in the neighborhood, or the SUD areas, or the aquifer recharge, and the gray water is separated and sent to an external grey water treatment facility. Since if it's difficult to have constructed wetlands, you can have a warehouse where what if it treats the grey water separately, and the treated grey water is sent for the industrial plants which were around the area, and for the reuse where water is used, and the grey water, the treated grey water can be used in those industrial areas or other areas, and it will create a synergy between different neighborhoods. And the excess water, the extra treated water, it can be sent to the tertiary treatment system in the wetlands, as we saw in the these areas. So, and it can be discharged to the water, to the river, or the groundwater recharge. So it kind of closes the loop semi, but we tried to. So yeah, so this was a proposal for the wetland area, how it can be made. So to break down the barriers, since this is the present condition of the river, and how you can blend the edges and you can connect the spaces. So, talking about the drainage systems in India, like we studied about Catalonia, that after 2008 drought, they heavily shifted from local water, which is the surface water, to energy intensive desalination. So, these both regions, that is Catalonia and India, they both regions face growing energy water nexus challenges. But India's problem is compounded by scale, its inefficient infrastructure, and improper management issues. So we also see some similarities between these two regions. Like if we talk about India, like Indian urban drainage systems face critical challenges since they are aging. Most Indian cities still operate British era or pre-independence drainage layouts. So it makes it very difficult for the maintenance or the change or the separation of the drainage water and the storm water. So, and also the aging infrastructure, the loss of natural drainage paths, and there is also encroachment of buildings, and there is poor maintenance and mixed storm sewage networks. So also in Spain, like we saw, like there is a mixed storm sewer networks, which is very non-sustainable in the current era, and we immediately need like a separate stormwater system, because when there is heavy rainfall, it waterlogs. It cannot, the drains cannot handle the peak flow, quick flooding, and it waterlogs the systems. So, and also the rainfall has intensified due to climate changes. So, also the urban expansion has covered the lakes, wetlands, open grounds, the natural stormwater challenges, everything. And otherwise, they have become like dumping grounds for the cities. So, earlier these used to act as natural sponges for runoff. Their loss leaves no space for water. There is rapid surface runoff because these are all covered, and there is urban flooding. So in many cities stormwater drains are double as sewage drains, so that's why. So yeah, in order to meet the future urban water challenges, there needs to be a shift in the way we manage urban water systems, and an integrated urban water management approach that should be adopted, which involves managing the freshwater, wastewater, which includes the gray water and black water separation, and the stormwater management. So also during my internship, which was it's not a part of like this thing, but there was the dry toilets are also very prevalent in these days when we talk about water, excess water usage. So EcoSan, I would like to share this part as well. So EcoSan, or the ecological sanitation. So this was a project that was under architect Lohofonia in Kolkata. So this was for a house in Baruipur area in Kolkata. It was a house for Linus and Rupsha. So EcoSan, so it was an ecological sanitation or a zero discharge toilet. So it separates the feces and urine, and it doesn't use water basically. So what it does is like um, it separates the urine, and then this is the construction of sorry, this is the construction of this ecosan. And I'll just say that, so the grave so the actually this is not there. So yeah, so the feces that gets collected separately, it can be used as like a manure for your community gardens or the backyard, everything. And the urine, it goes actually to the treatment systems, the root zone treatment system, which are basically the gray waters, the gravel beds of Cana Indica. So where the grey water gets treated, and it actually can be reused into the house again, in the flushing systems or small grey water other systems. So yeah, that's it. Thank you. Hello.
Yeah, thanks, Praeda, for the presentation. We can take questions now if any one of you have any questions or would like to discuss your thoughts.
Yeah, I
Okay.
just thanks, Preda. That was very interesting.
Thank you.
One, I'll come to my question, but before that, I just wanted to make a small comment. So,
Hmm.
I don't know how much you know about Biome, but our founder, Mr. Vishwanath, and
Yeah.
his wife Chitra, they had actually developed a model of an eco-sand toilet, which
Yes.
uh, which segregated the feces, the urine, and the wash water. So there were three
Okay.
openings for it, and the urine was collected, and it can actually be used for fertigation. It's used as a fertilizer because it's high in nitrogen. So
Mm-hmm.
that was it was interesting that you incorporated the EcoSan toilet in your presentation. So that was one. So I my question basically was,
Mm-hmm.
uh, does this SUDS approach, does it have what are the basic principles that it follows that in when you use it for design?
So basic principle, it also like depends, like it's as I said, it's like site specific. It needs to be because some of the SADs they take a lot of space and it cannot be implemented. So like swales, or like if you say the rain gardens, we see like mostly they are used in the residential areas, and in many places it's you can see nowadays in the new cities or the new planned cities, you'll see a lot of SADs actually getting implemented. So these rain gardens, which are very prevalent and very easy to make, build. So yeah, they are very site specific, and it needs to be studied the flow of water, like where the actually catchment areas are. So
Yeah, thank
yeah.
you.
Do we have any further questions?
Yeah, I wanted to check. I'm toilet that you showed. How is the treatment done, or is it done?
Ah,
How
yes,
does
yes.
it work? Yeah.
Yes, it's actually a very old project by sir. So, we actually saw the treatment like in the running phase of that project. So it actually works, and they were actually planning to expand the treatment systems. So I will show you once. Yeah, I think I didn't add it. Just give me one moment. Yeah. 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 So this is the system. So I'll go to this part. Is it? Yeah. Do you see this now? So the feces get collected here. The excreta that goes directly into these baskets and gets collected here, and the urine that goes into this part, which is collected differently, and then these goes to the beds. These you see, these are the Cana indica beds, and this water travels underground to these beds, which have gravel on the base, and this is the gray water that's coming from the bathroom or the kitchen sink and the washing areas and gets collected here, and it goes travels around this, and then right now it's not being reused, but yeah, you can reuse it, but that needs like further pumping and like in integration into the areas. So yeah, so this gray water is this is the road zone treatment system. the planted
Can
gravel
you
beds or the.
see your screen? Is it only me, or is everyone else able to see? If you're sharing the screen, that is.
Yes, yes, we are
Yeah,
able
yeah,
to
we are
see the
able to see.
screen.
Must be
Okay,
some
okay.
problem.
Oh,
Yeah,
you're
yeah,
not
please.
able to see? Okay.
No, must be some problem at my end. Please go ahead.
Okay,
Oh,
she's sharing the drainage system and the treatment system.
are you able to see now?
No, that's okay. Go ahead. Some problem at my end, I think.
Oh, okay. I'm so sorry.
No, no, no problem. I mean, it's not your fault. No, I mean, some my connection must be.
Okay.
Anyway, it's getting recorded, so I think we can have a look at it later as well.
Mhm.
Any more
Okay, that's good.
questions from anybody else? You can type them in the chat and we can take it up. Looks like, yeah, there is a question.
There are some questions in the chat.
Yeah,
Yeah,
I'm just reading
just now.
Please
those.
unmute and ask. There is a
Uh,
question.
There's one sent just now. Yeah.
Abhinav, do you want to ask or yeah, he's typed in the chat. So he says the global water stress map at the beginning showed that there are two worlds on either side of the tipping point. The projection showed that many of the developed countries would face low water stress, meaning that the adaptation has started. What are they doing already that we haven't caught up on?
Okay, so if I got it right, he's like, what are the basically adaptations by the developed countries that they are
Countries that
taking?
we haven't caught up on. Yeah.
Okay, I think, yeah, like in Europe, if we talk about, like in Spain, they haven't still caught up on this stormwater separation that we still in India also are facing. Like Netherlands had this issue, like they are a low-lying country, so they will get submerged very quickly, very soon. So they tried to adapt very quickly, and they actually took it very seriously, and they made sustainable this their whole city very sustainable water sensitive urban design, and they have water squares everywhere which where the water doesn't get flooded and it actually gets recharged. It's and there's like proper separation of the storm water and the wastewater. And yeah, and as I said in India, like when I was presenting that the drainage channels in India, which are the underground channels, it actually collects both, like the wastewater and the stormwater both. And during the heavy rainfall, obviously due to over flooding of the rainwater into the same drainage channel, it gets flooded, and it actually all goes into the it is directly discharged into the water bodies, or it goes into the wastewater treatment plants, and it actually reduces the capacity of the wastewater treatment plants. So there's an urgency in first having a proper stormwater management in the cities, because yeah, as we see the waterlogging conditions in the bigger cities which actually abrupts the whole lifestyle. So, and there are many, many examples actually. Many cities, like also you see the examples of wetlands in between the cities, also in bigger cities like Singapore, which are highly adapting to these changes quickly because they are one of the most water stressed countries. Uh, so yeah. Uh, does it reply? Does it answer your question?
Also, there is no design, right? I mean, which Indian city can be said to be properly designed? So there is a lack of a
Proper
thing.
urban planning and policies. So yeah, actually there was like a recent conference that I attended on the Indian Plumbing Conference, like where the people, the delegates from higher organizations, they were here. And the major issue of implementing was also when we talk about the rainwater harvesting, they are prevalent also like in the Indian system. When we see about the heritage systems in India, the Baulis or the other borewells or the other systems, uh, these all are like rainwater harvesting systems, and we need to know about our own heritage water conservation systems so we can revive them. It's also one of a big part of it. So, and also the rainwater harvesting system is mandatory, but it's not implemented properly. So we see there is a lack between the policies and the implementation. So the policies are there, some policies are there, but they are not mandatory. So until or unless there is a strictness there, I think uh, there will be a difficulty of implementation there. Do you
There was
have any
also
comments on
coming
this?
from somebody else. Wait, there was a Champa also had a comment. Champa, would you like to unmute and or share your comment?
Hi. That was, I know, I was just appreciating the work which was discussed and shown. And we really like the way from the macro scale of the urban area to the micro level in terms of how a small step also should be considered for the longer goal to
Yeah,
be reached. So, really appreciate the work which has been done.
thank you. Yeah, it actually like how you shift your perspective, like you also need to see the micro areas to actually make changes in the macro, in the urban built environment. So,
Yeah,
so what you
we
said
have,
was very,
no, I'll tell you the reason why we were like talking. We have
uh-huh.
done similar exercise at BARC
Okay.
level, fourth year level, for the city of Mysore, trying to look at the surface water as well as the drainage network. But the way you have taken it forward, the small step also matters a lot. So this becomes a learning for all of us. Okay, so
Thank
sometimes the
you.
students fail to see it. So I think somebody else has done it. So it becomes like a more like a case study and a learning. So that is where I feel you should be appreciated.
Thank you.
Any more questions? Or we can close the session.
Yeah.
So thanks a lot, Praeda. Thanks for giving the time, and this was such an very useful presentation, very detailed. And thanks for taking the time out, and all the best to you. Thanks to all of you who've attended today's session. And the recording will be available on our YouTube channel after a couple of days. Please have a look at it in case you have missed something in today's session. Thank you.
Thank you for having me. Thank you, everyone. Thank you, everyone, for joining.
Thanks, Preda.
Yeah.
Mm, Can stop the recording.